Salt is perhaps the most pure-looking ingredient in your entire kitchen. When you hold a handful of it, you see nothing but clean, dry, glistening white crystals. It does not look processed, artificial, or dangerous in any way. It carries the image of a simple, timeless mineral. But look closer. Under a microscope, some commercial salt samples have revealed something unexpected: tiny plastic fragments and fibers. These particles are too small to see with your eyes, and they are impossible to taste. Yet they raise a profound question about our modern world. When scientists place standard table salt under powerful lenses, the simple crystalline structure is no longer alone. Mixed among the sodium chloride are synthetic fibers, jagged fragments, and tiny polymer spheres. These materials do not belong in our food. They are the microscopic debris of our consumer culture, quietly integrated into an ingredient we use every single day. Finding these elements within a basic mineral shows that our global waste has spread far beyond visible garbage piles, reaching down into the fundamental seasonings of our meals. If plastic pollution can show up in bottled water, seafood, rainwater, and even tea bags, it seems almost inevitable that it would also hide in our salt. Today, we are exploring what the science actually says, without panic or exaggeration. Because the real story here is not simply that salt is dangerous. The real story is far more compelling. Even our cleanest-looking foods may now carry subtle traces of the world we have polluted. Salt has always enjoyed a powerful image of pristine purity in our minds. Sea salt feels completely natural, harvested directly from the ocean. Pink Himalayan salt feels ancient and untouched, preserved for millions of years deep inside the earth. Even basic table salt feels simple, refined, and carefully controlled. Chemically, we know that edible salt is almost entirely sodium chloride, a basic mineral that sounds incredibly clean. This reputation makes it difficult to imagine that salt could ever be contaminated by modern industrial waste. But salt does not simply appear in our kitchens by magic. Much of the sea salt and lake salt we consume is harvested through a beautiful traditional process. Large, shallow ponds are filled with water from oceans or saline lakes. Over weeks or months, the sun and wind slowly evaporate the water. As the liquid disappears, the minerals are left behind, crystallizing into the beautiful white grains we harvest. It is a highly natural method, but its reliance on open-air environmental factors introduces an unexpected vulnerability. The fundamental problem is that evaporation does not only concentrate salt. If the source water contains tiny contaminants, the evaporation process concentrates those as well. As the water vanishes into the atmosphere, any synthetic particles suspended in that water are left behind, trapped directly inside or alongside the forming crystals. The question is not whether salt itself is made of plastic. It is certainly not. The better question is, what else is being harvested from the water and brought directly into our kitchens? To understand this, we must look at the scientific evidence. In 2017, a major study published in Scientific Reports analyzed commercial salt brands from different countries around the world. The researchers tested 17 distinct salt brands sourced from 8 different nations. They dissolved the salt and filtered the liquid to extract any foreign particles. This study provided some of the first global data on how widespread this issue really is, offering a realistic look at the scale of microplastic contamination across international markets. In this research, simply looking at the extracted particles under a regular microscope was not enough. To be absolutely sure, scientists used a Raman spectroscopy. This process shines a laser on the tiny particles to analyze how they scatter light, creating a unique chemical fingerprint. This step is critical because natural materials like dust, clothing fibers, or mineral fragments can easily look like plastic under a microscope. By chemically confirming the material, the researchers ensured their data was accurate and highly reliable. The scientific results were fascinating. Out of the 17 brands tested, only one had no detected microplastics. The other 16 brands contained between 1 and 10 microplastic particles per kilogram of salt, focusing on particles larger than 149 micrometers. The most common materials identified were polypropylene and polyethylene. These are not rare or unusual substances. They are the exact same polymers used to make plastic packaging, bottles, food containers, bags, and caps. Our daily household trash is literally showing up in our food. However, not all scientific studies report the same findings. For instance, a separate Spanish study, also published in Scientific Reports, tested 21 commercial table salt samples and found much higher levels. They reported between 50 and 280 microparticles per kilogram. This is a massive difference compared to the 1 to 10 particles found in the multi-country study. Why would the numbers vary so much? The discrepancy highlights a major challenge in modern science. There is no single standardized method for counting microplastics. Measuring microplastics is incredibly difficult. Different research teams use different filter sizes, meaning some count smaller particles while others miss them entirely. Some studies count fibers while others exclude them. There is also the constant risk of sample contamination during the experiment itself, as plastic particles from laboratory air or clothing can easily fall into the samples. Because of these variables, we cannot point to one single number as the universal truth. The results depend entirely on how the study was designed and executed. Instead of focusing on a single alarming number, we should embrace the scientific nuance. The honest takeaway is that multiple independent studies have found microplastics, or plastic-like particles, in commercial salt, but the reported quantities vary widely. This does not make the science less reliable. Rather, it makes it more realistic. It shows we are dealing with a complex, widespread phenomenon that cannot be reduced to simple headlines. The presence of these particles is real, but the exact amounts we consume remain variable. So, how exactly does plastic find its way into our salt? The first and most obvious pathway is through our oceans. Every year, millions of tons of plastic waste enter the marine environment. Over time, sunlight, waves, and physical wear break this debris down. A single plastic bottle or shopping bag does not degrade into harmless elements. Instead, it fractures into millions of tiny pieces. Any particle smaller than 5 millimeters is classified as a microplastic, and these small fragments easily mingle with the seawater used for harvesting salt. But the ocean is not the only source. Microplastics can also travel through the air. Synthetic textiles, household carpets, and vehicle tires shed millions of microscopic fibers into the atmosphere every day. These light fibers are carried by the wind and can easily settle over salt evaporation ponds during the drying phase or drift into processing facilities. This means that even salt harvested from cleaner waters can still become contaminated by airborne dust and fibers during its production, proving that air pollution and land waste are deeply connected. A third pathway is the production process itself. After the salt is harvested, it must be transported, refined, crushed, and packaged. At every stage of this journey, the salt comes into contact with machinery, conveyor belts, plastic storage bags, and shipping containers. Minute plastic fragments can wear off this equipment and mix with the crystals. This is why even a highly purified product can contain microplastics. It is not just about where the salt comes from, but how it is handled in a world built on plastic. A common response to these findings is to change our buying habits. Many people assume that by switching from sea salt to rock salt or highly refined table salt, they can completely avoid microplastics. It is true that rock salt, which is mined from ancient underground mineral deposits, is isolated from modern ocean pollution. However, rock salt must still be mined, transported, processed, and packaged using plastic equipment. Table salt, though highly refined, undergoes similar handling. No single type of salt is completely insulated from our plastic-filled production chains. This means we should be highly skeptical of expensive marketing claims. Premium salts, such as pink Himalayan salt, coarse gray sea salt, or artisanal hand-harvested varieties, are often marketed as cleaner, healthier, and more natural. But a microscope does not care about clever marketing or beautiful packaging. Studies have shown that expensive salts are just as likely to contain microparticles as budget-friendly table salts. The aesthetic appeal of a salt crystal has no bearing on whether microscopic fibers are trapped inside it. Now, let us address the most important question. Is eating salt with microplastics actually dangerous to human health? Based on current scientific evidence, there is no need to panic. Scientists are still studying how microplastics affect our bodies, and the long-term health impacts are not yet fully understood. While there are legitimate concerns about chemical additives in plastics, or how extremely small nanoplastics might interact with our cells, we do not have definitive proof that the levels found in salt are causing direct harm. It is also vital to keep the scale of exposure in perspective. One study estimated that the number of microplastics we consume from salt is actually very low compared to other daily sources. We breathe in thousands of microfibers from indoor air every day, and ingest far more from bottled water, dust, and other foods. Avoiding salt entirely will not eliminate your plastic exposure. In the grand scheme of environmental pollution, the tiny fragments in your salt shaker represent only a very small fraction of your total daily contact with plastic. When it comes to the health risks of salt, the science is very clear. The biggest, most well-documented danger in your salt shaker is not microplastics. It is sodium. Eating too much sodium is directly linked to high blood pressure, heart disease, and strokes. If you want to make a meaningful decision for your health, focusing on reducing your overall sodium intake is far more beneficial than worrying about microscopic plastic particles. The proven cardiovascular risk of excess salt remains the primary health concern for consumers. So, how should you manage your salt intake in daily life? First, do not waste money on expensive, fancy salts assuming they are safer. Instead, focus on using less salt overall, which naturally reduces both your sodium and your microplastic exposure. Second, make sure to choose iodized salt if iodine is lacking in your diet. Many trendy, unrefined salts do not contain added iodine, which is an essential nutrient for thyroid health. Looking natural does not automatically mean a product is nutritionally superior or safer for your family. If you want to reduce your overall exposure to microplastics, there are areas where you can make a much larger impact. For example, avoid heating food in plastic containers, as heat significantly accelerates the release of microplastics. Try to limit your use of bottled water and plastic-lined disposable cups for hot beverages. Opting for glass, stainless steel, or ceramic containers in your daily routine is a highly effective, scientifically supported way to decrease your plastic exposure, far more than stress-buying expensive salt. The story of microplastics and salt is not a simple story of a contaminated food product. It is a story about the closed-loop cycle of our planet's environment. The plastic packaging we discard, the synthetic clothes we wash, and the waste we fail to manage do not simply disappear when they leave our sight. They fragment, travel through the air and water, and eventually return to our tables. It is a powerful reminder that our environmental footprint is not separate from our daily lives. It is intimately connected. Salt was once the ultimate symbol of purity. Today, finding microplastics inside it challenges that illusion. It shows that our environmental footprint is no longer just a distant crisis in the oceans. it has quietly returned to our plates, reminding us that we cannot pollute our world without eating from it. Which salt do you use most at home? Let us know in the comments below. In our next video, we will explore another common kitchen item that might be shedding plastic into your food: plastic cutting boards.